For this problem, we're asked to find the composite of two different functions in both directions, as well as the composite's domain. So we start with the first function, f of x is 3x plus 2, second function, g of x is square root of x, and we're going to compose f of g of x. So that little circle there means composition, it's not the letter O. So what that means is f of g of x, and I'm saying it exactly the same way, but I'm writing it differently. That is, the g function is the inner function. So what we're going to do is grab the g function, the square root of x, and we're going to insert it into the outer function everywhere there's an x. So that'll look like this. We're going to, like I said, replace g of x with square root of x. And then we're going to take that and put it into the f function in place of the x. So 3, and instead of x, square root of x plus 2. Now in this problem, there's not much more we can do with that to simplify the expression. So the function 3 square root of x plus 2 is the composite of f of g of x. Now in terms of the domain, we have to start with the domain of the inner function. And in this problem, the inner function is square root of x. So the domain of square root of x are all the numbers greater than or equal to 0, since we can't take a square root of a negative number. We could also write that using interval notation, that is a bracket. 0 is our starting point, comma, everything to the right, all the way out to infinity with a parenthesis. Now we have to be concerned with the domain of the outer function. And I'm just using the f for function, not the two specific ones. And in this case, that's 3x plus 2. Now the domain for 3x plus 2 is all real numbers. We can write that with our fancy looking r, or in interval notation, negative infinity to positive infinity. And since there's no restrictions for the outer function, that tells us that the domain of the inner function is the domain of the composite. Now what's a little tricky about these is you can't just look at the answer for the composite to determine the domain. You have to go through this sequence of starting with the inner function and then what's coming out of the inner function going into the outer function. Turns out in this problem, they're one and the same. Okay, let's look at now the composite going in the other direction. So let's rewrite our two functions. Guess we're in blue, but that's okay. 3x plus 2. And our g of x is square root of x. So for this problem now we want to go in the reverse order. So we want to take g of f of x. That is, the g comes first. So as before, we said that means the g is on the outside, and the f function's on the inside. So we're going to take our f function, which in this case is 3x plus 2, and we're going to insert it everywhere there's an x in the g function. So g of 3x plus 2. And now inserting that into the square root of x, we get the square root of 3x plus 2. And just like the previous problem, there's nothing we can do to simplify it, reduce it, so that is our composite function. And now we'll talk about the domain. So the domain of the inner function, which this time around is 3x plus 2. We already said that the domain of that is all real numbers, or in interval notation, negative infinity to positive infinity. So no restrictions on what can go into that. But the domain of the outer function, which is the square root of x, we know does have a restriction. Let me move that up so we could have a little bit more room. So we know that the input must be greater than or equal to 0. Now, the reason I wrote it that way this time is because our input isn't x, our input is the inner function. So that's 3x plus 2 is greater than or equal to 0. And solving that, we first move the 2 to the other side. That gets us negative 2 over there. And then divide by 3, a positive number, so the inequality doesn't change. And we get x is greater than or equal to negative 2/3. Or, in interval notation, whoops, sorry, that's a bracket, negative 2/3, comma, infinity. Now, because there were no restrictions on the inner function, we just focus on the restrictions in the outer function. So that means our domain for the composite is either in inequality notation, x is greater than or equal to negative 2/3, or interval notation, bracket, negative 2/3, comma, infinity.